Okay, so welcome to my video tutorial on the silo problem that I've set you guys. I'm hoping that you guys have really given a good crack at this and that you've managed to kind of acquaint yourselves with the problem. In terms of these video tutorials that I'm going to create here, uh, I'm not gonna spoon feed you along the way. I'm basically just going to kind of show you how I would approach this problem. And hopefully you guys should be able to kind of follow along and see my logic. Now, if you've worked hard on this problem already, you'll probably already know that you can kind of split it into two sections. So the first section is this section here, where you're basically being asked to draw out the dimensions of the liquid storage silo, and in the fifth bullet here, you're asked to determine an area of an orifice through which the liquid can drain from the silo in a precise amount of time. And these are, yeah, like I say, these are two distinct problems, really. So this first video tutorial, I'm going to show you guys how to do these first four bullets, sort of. And in the second video tutorial, I'm going to show you guys how to do what is essentially a calculus problem with the area of an orifice. So welcome to video tutorial 1. This is how I'd approach the problem. So for starters, I'd say that 0.9 VT is equal to 12 meters cubed. Well, I don't need to write meters cubed there at all, do I? So I can say 0.9 VT is equal to 12. The reason I can say that is because if 10% of the silo is ullage, then 90% of it must be this 12 meters of water here. So I can say this, that 0.9 VT, where VT is total volume, is equal to 12. I can rearrange that. I can say VT is equal to 12 over 0.9, and that is equal to 13.3 recurring. Okay, so I've got my first value. Where would I go from here? Well, I'd look at that and think, oh, as a circular base, okay, well, I can say that the cross-sectional area is equal to pi r squared, because that's the area of a circle. Has a 3-to-1 inner height to width ratio. So what that basically means is if I had a width of 1, then my height would be 3. If I had a width of 2, then my height would be 6, and so on. Therefore, H must be 3W. And I'd also look at that and think, well, W, if I'm thinking about a cylinder here, W isn't the radius. The radius would be kind of this length here, right? But W would be the whole width of the silo. So width and diameter are kind of interchangeable here. I can say W is equal to 2R. Okay, so I've said a bunch of stuff. I might ask myself, is this solvable? Well, let's have a look. So if I want to ask myself, is this solvable? I'd probably want to ask myself, how many unknowns do I have and how many equations do I have? So how many unknowns? Well, that is not known, that is not known, that is not known, that is not known. I have 4 unknowns, okay? How many equations do I have? 1, 2, 3. Okay, this isn't solvable yet. I need to derive another equation if I want to solve this, or I want to make one of the unknowns known, right? I can't do that, so I need to derive another equation. I could say then that since this is a cylinder, the total volume, so VT, is equal to the cross-sectional area times the height of the cylinder, okay? And I know my total volume is 13.3 recurring, okay? Is this solvable now? Yes, because I've got 4 unknowns and 4 equations. I have as many unknowns as I do equations, so it must be solvable. All right, well, let's have a go at solving it then. So how would I solve this? I'd probably look at this and think, well, I've got 13.3 recurring is equal to ACH. And think, okay, well, I can express H as 3W and I can express W as 2R. So I could probably express H as 6R, right? So I'd say then that, let's be consistent with my colors, 13.3 recurring is equal to AC, 6 ACR, so I've basically substituted 6R in for H, and then I can substitute my pi r squared in for AC, and I can say that 13.3 recurring is equal to 6 pi r cubed. Okay, so let's just bring this down. So 13.3 recurring is equal to 6 pi r cubed. So is this solvable now? Well, yes, because I have one unknown in it, right? Just r. So I can rearrange for r. So I can divide through by 6 pi and then cube root it all, and that will give me r is equal to the cube root of 13.3 recurring over 6 pi. And when I bung this into my calculator, that gives me something in the region of 0.891 meters as my radius. Okay. Am I done? No, obviously not. So I've got my radius, but I don't have my width or my height. Okay, well, if width is equal to 2r, then I can say that width is equal to 1.782 meters, and if h is equal to 3w, I can say that that is equal to 5.346 meters. Okay, so I've got these dimensions here. Now, if I just go back to my problem that I emailed you guys, I said, please reply to this email with labeled drawings of a liquid storage silo that meets the requirements listed below. So the first part of this problem is basically just to draw a label drawing. I also attached a copy of a picture, which is taken from some work that I did in my third year. But obviously you guys won't be producing something as kind of granular as what I've pasted there. It's just for inspiration. So what your diagram might look like if I'm drawing a side view of this silo here, well, the width is equal to 1.782, or the inner width is equal to 1.782. So let's get some red in there. I'd say this width is equal to 1.782. Now that's the inner width, right? So I could also draw the outer width here. Oh, that's awful. Hang on. So this space that I'm highlighting here is kind of like the wall of the silo. And if you'll remember, it's 5 centimeters thick. So if that's 1.782 in length, I could add to my drawing here and say 0.05 meters. This length here would be 1.782 meters plus 10 centimeters. So that will be 1.882 meters. And then my height, or my inner height, is 5.346. This is just a sketch, and I wouldn't expect anything um, all that rigorous from you guys. So 5.34 inner height there. I'm going to draw over what I've already done, but whatever. Okay. And that will be 5.346 plus 10. So that would just be 5.446 meters. And yeah, if well, you could go even further and draw some water in there. Maybe even label up the height of the water. And then maybe use yellow just to show my ullage or something. I wouldn't expect, yeah, so I wouldn't expect anything any more detail than this kind of thing from you guys in your email. Consider drawing it by hand. Consider drawing it using some kind of CAD software. But if I saw an email like this, including some of your workings as well, I would be a very happy bunny. So this is kind of how I would approach the first part of the problem. In the second video tutorial that I'm going to create here, I'm going to show you guys how I'd approach the second part of the problem.